Today we'll be going ahead with two super basic and easy topics. The first one being data types and the second one we'll look at is operators. So let's just jump right in and give the brain something to munch on. Cool? Okay. So data types. What are they? They are simply an attribute of data that the compiler or the interpreter uses to understand what the programmer is intending to do with that data. So if you guys have had experience with C or C++ before, you will know that when declaring a variable, you need to specify the data type. For example, int a is equal to 10. The statement means a is an integer whose value is 10. But Python is a loosely formed language and we therefore don't need to specify the data type. Like here, this piece of code, we are declaring a is equal to 2. So the compiler knows a is an integer of value 2. We are declaring 8 different variables over here, each with their own data type. So 8 different data types. So here a is an integer, b is a float, c is a string, d is a tuple, e is a list, f is a dictionary, g is a set, and h is a complex number. So what we're trying to do is we're trying to output the data type of those 8 variables. So how that would be is print type of a. This would display the data type of the variable a. Similarly for all 8 variables, and there's an extra print statement here where we're trying to display the data type of the value true. So true is of bool data type. So 9 different data types have been introduced just here. Also note that unlike C or C++, we don't need to put a semicolon at the end of each statement. You can simply write it and that's it. Okay, moving on. Each variable in Python is an instance of an object. So there are 2 types of objects in Python, mutable and immutable objects. So this is a little flow chart that shows what comes under what. Number, strings, tuples come under immutable, list, dictionary, sets come under mutable. So let's look more closely at what they are. So immutable objects are those objects that can change their state or contents after creation in the program. So numbers, strings, tuples are immutable like we just saw. Okay, here a is a string, Python, we're printing the data type, that's fine. And we're changing a of 0. A of 0 is basically the first character. The first character is a of 0, second is a of 1, third is a of 2, and till the end. So we're changing the first character to a lowercase p and then trying to print the variable a. But this third line of code comes out as an error because item assignment is not supported by string objects, which is basically referring to the mutability property. So strings don't support mutability. They can't change their content. Here a is a tuple. We're printing the data type and we're changing a of 1. That is the second position value. A of 1 to a of 0 plus a of 1, which is 1 itself. But either way this third line doesn't happen because again tuples don't support mutability. Moving on to mutable objects, like the word suggests, it basically is the opposite of immutable objects, which means these refers to objects that can change their status or contents after creation. So list, dictionaries and sets come under mutable objects. Here a is a list, we're printing a data type and we're changing the second element to the sum of the first and the second element, which is 1 itself, and we're trying to print the variable a. And this happens successfully because lists support mutability. Here a is a dictionary with the a, b, c fields carrying values 0, 1, 2 respectively. We're printing the data type and we're changing b field's value to the value of c field. So we are assigning 2 to b field and we're printing the new dictionary, and it happens like we intend because dictionaries support mutability. Moving on to the next subtopic, typecasting. Typecasting refers to one of the many ways you can change data type of an expression. So with typecasting, you can convert one data type to another. So these 5 are the inbuilt typecasting functions provided in Python. Let's look at them one by one. So the first one is typecasting to int. So every other data type can be converted to int. See here, a float, a string, and a bool value is converted to int. And it happens successfully. This is how you do it. Int of whatever the value. So here what we're trying to do is displaying the data type of the value that we just converted to int. So this was float converted to int. So data type of that float converted to int would be int. So all are int because all are converted to int. Now let's look at some error cases. Here we have given ten, the word 10 as a string to the int function. And ten are not integral values. So this comes out as an error. So this ten are letters are invalid literals for the int typecasting function. And complex numbers too can't be converted to int. Okay, I will show you the correct error statement for that. So what the hashtag does is it comments out those lines. Basically, it's just for us to read. It is not part of the code. So yeah, complex can't be converted to int. Simply, that is the simple error. Okay, just keep it as it is. Moving on to typecasting to float. Float too, just like int, every other data type can be converted to float except again for complex. So int is converted to float, string is converted to float, and here note that this string has a decimal point as well, because decimal point is also a floating point literal, and floating point literals in a string can be converted to float, and bool value also is converted to float. All are successfully converted, so that's fine. Now typecasting to complex. Int, float, string, and given a tuple with just number values or a true and false. True and false is basically 1 and 0. So the complex number would be 1 plus 0j. So even a tuple can be converted to complex numbers. All are successfully converted. So all data types have printed as complex. Now let's see what happens if I give a tuple to float or int. I'm giving it a float, but obviously we have to change this to float because we want to convert it to float. And I'm going to print this. And this is the fifth line. The fifth line of code shows an error because the float typecasting function doesn't know what to do with two separate values. The float function expects just one argument, but we gave in two. So it comes out as an error. And the same error happens for int typecasting function too. Now moving on to typecasting to bool. Here int, float, string, and complex number, etc. all are converted to bool. You'll notice that empty string. So empty string, a 0 complex number, a 0 float, a 0 int are all evaluated to false, and any other value is evaluated to true. So all these are successfully converted to bool data type. Okay, moving on to the last one, typecasting to string. So here int, float, bool, complex all are converted to string, and this is how they would look in a string format. And all are converted to string, no problem. So that brings us to the first topic. Moving on to the second topic, that is going to be even more easier and even more familiar to all of you. That is operators, which is, suppose I say a plus b is equal to 2 means plus and equal to are the operators. So there are 4 types of operators: arithmetic operators, logical operators, comparison operators, and assignment operators. So let's look at them one by one. Arithmetic operators are the ones we have known since forever. Addition, which is represented by the plus sign, gives the sum of two numbers. 1 plus 9 is equal to 10. Then subtraction, represented by the hyphen or the dash or the minus, whatever you call it, symbol, gives the difference between two numbers. 10 minus 3 means it will give you the answer as 7. Then multiplication, which is represented by the asterisk symbol. So this means 5 asterisk 2 is 5 into 2 will give you the product 10. So asterisk gives the product of two numbers. And division, represented by the forward slash, will give you the quotient between two numbers. So 11 divided by 2, the quotient is 5.5, and that is what is displayed. You will note that unlike C or C++, where the answer would be just 5, here it's the exact answer 5.5, even though the numbers given in are integers. Okay, so between multiplication, division, addition and subtraction, there is a precedence where multiplication and division has a higher precedence than addition and subtraction. So this particular expression 2 plus 3 into 10 wouldn't be solved as I read it. It would be solved according to precedence. So multiplication has a higher precedence. 3 into 10 would be done first. So that evaluates to 30, and then I would add to 30 plus 2. 32 is the final answer. In the case that the expression contains only operators of the same precedence, you simply solve it left to right. So the way I read it, 6 divided by 3 into 4 would be the way you solve it. 6 divided by 3 is 2, 2 into 4 is 8. So 8 is the final answer. Next is the modulus operator, which is represented by the percentage sign. It gives you the remainder of two numbers. Like when you divide two numbers, whatever the remainder is, it will display that. So 5 divided by 2, if you're considering only the integers, the quotient would be 2 and the remainder would be 1. And here what is displayed is 1, the remainder. So modulus gives the remainder. The next two operators might be ones that are a little less familiar. So exponentiation, while the operation is familiar, raised to is how we represent it. But in Python, it's a double asterisk. So 5 double asterisk 2 means 5 raised to 2, 5 or 5 to the power of 2, and will give you the answer 25. Next is the floor division operator, which is double forward slash, which basically returns the largest integer that is less than or equal to the quotient that you get from the division between these numbers. So 7 divided by 3 answer would be 2 point something. So what gets displayed is simply 2. So suppose I write 1 here. 7 divided by 1 quotient should be 7. And 7 is an integer. So what is displayed is just the integer 7. Because it's less than or equal to. But if I give 2 here, the answer is 3.5, but that's not an integer. So the largest integer that is less than or equal to 3.5 is 3. So 3 is what is displayed. Now the order of precedence of the operators we saw is parentheses or brackets have the highest priority, then exponentiation operator, then multiplication, division, floor division, modulus, all are the same precedence, and plus minus have the same precedence. So this expression that is given right here, parenthesis has the highest, so 2 minus 1 would be solved first. The answer would be 1, then exponentiation, so 3 raised to 1, which is 3. Then multiplication is the next precedence, so 2 into 3, 6. And finally, addition, 6 plus 1 will evaluate to a final result of 7. Moving on to the next class of operators, the assignment operators. So basically, just 1 equal to is an assignment operator. 2 is assigned to the variable a. That's what this means. And a plus equal to 1 simply means A is equal to A plus 1. So here plus equal to is also an assignment operator, and this expression is a shorthand for this expression. So A plus equal to 1 means A is equal to A plus 1. So A plus 1 is 2 and the value A plus 1 is 2 plus 1. 3 value is stored in the variable A, and when you print A, value 3 is displayed. Similarly, for minus, A is equal to 3. A minus equal to 1 means A is equal to A minus 1. So 3 minus 1 is 2 and the value 2 would be stored in A. So when you print the variable A, you will get the output as 2. So just like plus and minus, all the other arithmetic operators also have their own shorthand or assignment operators. So it will look the same way. Into equal to is equal to A into 2. Division, modulus, flow division, exponentiation, all have their own shorthands. Moving to the next class, comparison operators. So first one is equal operator, which checks if both the sides are equal. So it's a double equal to symbol. So 5 equal to 5 is a correct statement, so it will return true. 3 equal to 2 is a wrong statement, so it will return false. Then the next is the not equal operator, which is an exclamation mark and an equal to sign. So 2 not equal to 1 is a correct statement, so it will return true. 2 not equal to 2 is a false statement. 2 is equal to 2, so it will return false. Next is the greater than symbol. We all know this. 5 greater than 3 is true. This is correct. 3 greater than 3 is wrong, so it will return false. When I see this, I still remember how in KG classes they used to say this is the mouth of some animal, and whichever is bigger it will eat. Anyway, moving on. Next is the less than symbol. So 3 less than 5 is correct, so it will return true. 2 less than 2 is wrong, so it will return false. Next is the greater than or equal to symbol. 5 greater than equal to 5 is correct, so true. 4 greater than equal to 5 is wrong because 4 is not 5 or 4 is not greater than 5, so it will return false. Then less than or equal to 4 less than or equal to 4 is correct, so true. 5 less than or equal to 4 is wrong, so false. The final class of operators is the logical operators, which is the AND or NOT operators. So AND operator evaluates to true if both the sides or both the conditions are true. So true and true would give a true. Every other condition, that is true and false or false and false or false and true, all would be evaluated to false. Both needs to be true for a true. So a detailed expression would be like this. 1 equal to 1 is a correct statement. 10 greater than 5 is also a correct statement. So true and true would give a true. But here 1 not equal to 1, that is a wrong statement. 10 greater than 5 is a correct statement. But false and true will evaluate to a false. Next is the OR operator, which will evaluate to true if either one is true. So true or true and true or false and false or true will all evaluate to true, but false or false will evaluate to false. So 1 greater than 2 is a wrong statement. 5 greater than 4 is a correct statement. So false or true would be evaluated to true. Next is the NOT operator, which will basically give the opposite of what is stated. So if it's true, then we'll give false, and if it's false, it will give true. So if I say not true, it will give you false. If I say not false, it will give me true. So I say not 1 greater than 2. That means 1 greater than 2 is a false statement. So not false would give me true. And here 2 greater than 1 is a correct statement. So not true would give me false. Now the order of precedence of all the different operators that we just saw is this way. Arithmetic has first precedence, then comparison, then logical, and then assignment. So this particular expression, how it would be solved is the arithmetic first. So 1 plus 2 is equal to 3 and 4 plus 5 is equal to 9 would be evaluated first. Then comparison operators. So 3 greater than 4 is false and 9 greater than 6 is true. So that will be the next step. Then the next operator that has the next precedence is the logical operator. So logical operator refers to this OR. So false or true would be evaluated to a final true. So that brings us to the end of the second topic as well. So hope you guys gained something from this lesson. See you guys in the next video.